All right, guys. Make sure you guys grab all that stuff I asked for. Okay. And Kylie, Catriella, have your test. So come up here and grab your Catriella, you're right here. Kylie, you're right here.
Oh, great.
Anna Gould. He's already been logged in. Too.
No, wait, Mr. Mason. I thought my online said 97.
What'd you say?
This is 95 on it, but my online says I have a 97.
You wouldn't have given that away. Leave it as.
I'm not really sure which one's the right way.
No, yeah, I don't know either. So we'll just, leave it. Okay. All right. We're gonna kind of get right into it, guys. Grab your handout that you're looking at right now, or grab the handouts that we kind of looked at. We're gonna be talking about proofs, actually, for the first time. Okay. So let me paint you a picture, okay? So before math, guys, wasn't really just procedural. Like math right now, the way it is just 2 plus 2. Let's figure out the roots, right? You have to memorize a bunch of steps. You can imagine, we should possibly, okay? I just don't want her to miss me out. Hello there, what's your name? Haley, that's right. Why don't you grab a seat and then just have a seat somewhere. We're all sitting at the table, so you can see Dave. We're about to launch into our lecture right now. And also grab one sheet from those stacks over there. One of each.
Yeah.
CJ, you see anybody else in your class?
And Kylie.
I'm walking out the person.
You're the third Kaylee.
I don't know.
Okay, I just don't want to start lecturing and then you guys are coming.
Yeah. Yeah, both of them.
Okay. So very good, and get your sights set on this handout right here, right? Today we're going to start a big part in math called proofs. And in order to understand proofs, you kind of have to have some context about what math was before. Do you think math was always this way? You have to go to school, come in for about an hour, you need a very dull teacher.
No.
Okay, you think math was always like? Imagine what math was like before.
Was it kind of similar to how chemistry was before it was just classes?
That's true. Yeah, it was actually. It was a lot more creative.
Like, there was a lot of concepts, and instead of it being a set formula, it was just discovering those formulas. So it was a lot of work and a lot trickier. It took a lot of people checking each other's work and trying to disprove others, right?
Yeah, in fact, it was actually a thing of debate. It was philosophical. So you guys can imagine in the Greek times, people wear robes, okay, discussing what is 2 plus 2? Is it the same as 2 minus 2? And in fact, we know now that's not the case. 2 plus 2 is not equal to 2 minus 2, right? But we were at a point where we did not know. It was actual philosophy. And then from philosophy, we kind of found postulates, theorems, and truths that always consistently worked over and over to a point where it's a universal language now, right? We're entering the part in math where we finally look from the perspective of a Greek philosopher. Proofs. We have to, in order for things to work, there has to be reasons behind why they work, okay? These are your introduction. This is a brief introduction to what proofs or truths you're going to see. So let's take a look, okay? For any 2 points, there's exactly 1 line. Why don't you guys take your hands right now and then just kind of look around. These are your 2 points, okay? At any point now, could you make a line between these 2 points in your hands? How about you, Truman? Could you make 2 points between your line between your 2 points? CJ, I know you got yours right here. Okay.
Yeah.
Okay, right? Yes, you can make 2 points, right? That's the truth. Huh? Yep, easy way to do it. You can, but I can. Well, yeah. Well, I can do this. Can you do that with your pencil? But I know if your pencil could go along with your 2 points, it would still be a line, right? Be a straight line. Okay. that's one truth. Okay, three non-collinear points. There's exactly one plane. What is non-collinear? What do you think non-collinear?
We don't all make a straight line.
And what do you want to add to that material?
I was gonna say that, but I guess not.
What are you gonna say again?
What she said,
That the points are.
yeah, like they aren't, connected straight.
Yeah, so if it's 3 points, so you guys got the two hands, you can use any other object you want on your body, and you got the point, so I'm gonna use my head, okay? You can, so I would recommend you use your chest, something, okay, okay, let's just use your head, okay? Use it, oh, look at that pun, okay? Use your head, okay, that's a point, and then move your point anywhere else. Do it right now. Okay, I know this is ridiculous. Freeze, okay? Just freeze right there, okay? Get it on. Okay, don't move, okay? Right now, actually, yours is gonna hurt the most, so I can't do that. Okay. Let's look at Katie right now. Could we make a plane with 3 points that she has right now? Her head and 3 points. If I lay this flatly, that makes it a plane. Is that a plane? Okay, very good. Great. Thank you, Gillian. You're not done. Okay. Oh, again, the position that he's in, can we still make a plane with his 3 points? That's, okay. Cool. Okay, yes, yeah. That's definitely a plane. Okay, very good. CJ. Okay. Oh man, you gave me a challenge, didn't you? Okay, all right. Well, that's so bad. Okay. Is that a plane, Truman? Only Truman can see the truth. Yes. Okay. Thank you, Truman. Yes, that is a plane. Anybody else want to give it a try? Potato? No, potato. That's a hand down. Catriella. Okay. We have a plane here. Inside the head. Okay. Looks like she's holding a bird on the weight of her shoulders. The weight of the world on her shoulders. Or no, that's a plane. Okay. All right. So we've proven that. Yes. Are there any 3 points in space? There will always be a plane, right? A line can. Okay. This sounds exactly like this one. What's different between 5.1 postulate? By the way, that's not the actual name of the postulate. Can't imagine a Greek philosopher. Postulate 5.1. Okay, there must be a name for it. We don't know what the name is, right? We'll just call it 5.1 and 5.2. What's the difference between postulate 5.3 and 5.1? They sound exactly the same. Any?
Have more points.
Yeah. A line contains at least 2 points. Okay.
At least, which could mean more, and then it says through any two, there's exactly one line, which.
Oh, okay. So 5.1 is a scenario where 2 points make a line, but the other one is if we already have a line. Okay. How many points need to be on it? At least 2. You can have more, right? What about if we have 1 point?
That's just not a line.
That's not a line. That's just a point. Okay. Interesting. Right? How about a plane? Okay. So again, 5.2 and 5.4. What's the difference between these two things? A plane contains at least 3 non-collinear points, and through any 3 non-collinear points, there's exactly 2 different circumstances. That's correct. Anybody else want to add to this? You, Katrina?
Well, it's the first one, like 5.2, is saying that, like, when they say through any 3 non-collinear or collinear points, there's exactly one plane. That's referring to the, like, if you're talking about the point,
Yeah.
you
Points.
could, like, it's conjecture based on what the points are, and
Uh-huh.
then in 5.4, a plane contains at least 3 non-collinear points, is referring to the plane, and conjecture using the plane is saying, like, if you are given, like, a box or whatever that's shaded in, and it has a grid in it, and they're saying, show us, like, with the postulate 5.4, then you put 3 points on the grid inside of the shaded box.
No, that's absolutely correct. So yeah, so one is talking about 3 points, make a plane. The other one is, let's just talk about the plane itself. You need at least 3 points in it. Does that make sense? Okay. The last one looks tricky, but indeed not. Okay. Allison, hold on to your papers. Okay? You hold on to these papers and hold on to them like this. Okay. You hold them down with your hand. Okay. Okay. Don't be scared. Don't be scared. I'm just showing this to you guys. Okay. This is a plane, right? And let's just say, let's spread them out a little bit. Right? Between these 2 points, would you say there's a line?
Yes.
Okay. Is there any way you can make this line and not be on this point? the thing is, these 2 points are on this plane, right? If I make a line, can the line flip off the plane at any point? Again, the condition is these 2 points must stay on this plane. Okay? So that means, what does that mean about the line that it makes between these 2 points?
Is it specific to that line?
Yeah, that's exactly what 5.5 says right there. 2 planes line to plane, the entire line containing those 2 points. Okay, sorry about that. I hit your foot. Okay, sorry about that. Oh, yeah, fun, really cool. Okay, math was fun, right? Okay. I think we got 2 more, and that's about it, folks. Okay, if 2 lines intersect, there's exactly 1 point. Maybe a little swash. Everybody grab 2. Okay, how about you and a partner grab 2 rulers? It's just a quick exercise, really quick. So in here, that is forced will. I want you to do this. Horrible stereotype.
Penguin. I'm sorry.
So grab 2 of those things.
And Blues Brothers, the penguin. I made a Blues Brothers reference.
Oh no, yeah. See, I haven't watched that. Wow, that's you really go back in your old school references.
I do.
Okay, and we're running out of rulers.
Really?
Okay, cross
Really?
take your rulers and cross them. Any, make a weird T, make any shape that you want. Okay? Let's just pretend these are perfect lines with no thickness. These are just straight lines, okay? How many points do they intersect at? These are just straight. One. What about right now? One. What about, oh, they're still intersecting, okay? So you just keep it out just a little bit. How many points? 1. Still only 1, right? No more than 1. I mean, some of you guys are like, well, that means the microscope. If you look at it, it's actually more points. Just use your imagination, okay? Just say these are perfect lines. No thickness is what I said in the beginning, okay? That's 5.6. And the last one is what if you have 2 planes that intersect? I did this before. I'll do it again. Okay. Okay. Use your imagination because okay. Here's the plane. A little bit of magic. Right? Take this one. Cut it across, and it comes on the other end. What? Isn't that crazy? Well, how would you define? So we knew that 2 lines when they intersect at 1 point. How would you describe the intersection between these 2 lines? Yeah, is it a point? Do they intersect at a point? No longer a point. They intersect. Yeah, these are 2 planes. Go on. You look closely. Again, these aren't even paper thin. They're just super thin. You should get. How would you call this point of intersection? Is it a point anymore? It is a. What did you say it was, Patrick? It is a straight line. That's what 5.7 is. If 2 planes intersect, the intersection is not a point. It's a straight line. Everybody see that? Okay. Don't mind the gaps. Okay. I know you're looking for like little details.
No, I'm just trying to get out of having to give the details.
Just mess on it. What are my tools? Those are your tools for this section, right? And one last thing that you might want to learn is the midpoint theorem. Read this to yourself really quick and tell me what it means in terms of this line. What do you think this is saying? This is very complex stuff. We want to do a try about what this definition is saying. It's like I'm giving you a law, and I want you to recite what this law is telling you. On.
Wait, I just had something too. That the midpoint will make the 2 new lines equal.
Yeah, simple as that, right? I love it. Okay. All laws are just like this. Okay? You just gotta break it down in simple little terms. Okay. So they use an example. M is the midpoint of this 4-line segment, and it makes 2 lines that would be equal. Confusion? It's by definition, that is a midpoint. Okay. With these 8 new truths that you might have already known or might not have, okay, we can do a lot in this section, right? So we're gonna do a few things. So first, let's see. Let me grab a book really quick. I'm gonna go through some stuff with you here. There's some exercises in this section that I think are pretty nice. So I'll be honest with you. 5-1, pretty fun, not too bad. It's a little weird to do on your own, but I'll show you what you have to do. And then 5-2 is where things get a little bit more serious. Okay? But hopefully still a little bit of fun. Just have a little bit of fun with this. Okie dokie. All right. Let's see here. What are we doing here? Okay. Let's see if I can get this here. Okay. So we have here to our. Can you? All right. Sorry about this. This is me attempting to block out what is the actual answer right now. Okay. Let me focus on here. So I have a picture to my right. Okay. Does anybody see any interesting shapes or things occurring in this picture here? I see angles. What else do I see in here? Like I see a lot of lines. That's good. Okay. But a lot of planes. Okay. Well, I don't see any planes, young lady, but I see some flat planes. I'm just kidding. Okay. That was an airplane joke. I got you good. Okay. All right. Okay. So it says, explain how the picture illustrates that each statement is true. So let's take a look at the statements. Then state the postulate. How many postulates did you just learn? Quiz time. Yeah, you learned about 6. Learned about 6 or 7. Okay. 6 or 7. Man, it's about the same. Okay. Then state the postulate that can be true. So look, line M, if you look here, this is line M. And within this line, there are some points. I believe that's F, G, and let's see, E, right? Discuss with your table what postulate best describes that scenario. That line M may contain those 3 points. Okay. Please discuss with each other. Which postulate are we looking at here? Did we come to a conclusion here? What postulate best describes this guy here? The opposite of 5.1, which is, what'd you say? Okay, let's take a look. Let's see. A line can contain at least 2 points. Oh! Well, look at that. Yes, sorry. Okay. Postulate 5.3, which states that a line can contain at least 2 points, shows that this statement right here is true. Okay, very good. Now I want you to go up on the board. Okay. So Kaylee is going to be your first experience. All right. So watch out. Okay. Don't poke an eye out. Right. I want you to write down the answers for for B, 1-A, and 1-B. Give it a try. Just write down the postulate number, 5.1, 5.2, 5.3, 4, 5, 6, 7, 8, 9, 10, whichever ones they are. Okay, guys, go ahead and get started. I'm going to pause this screen, okay, and you guys get on the board and write it down. Okay, that's all the math you're doing right now. Oh, okay. You're very observant. Yes. Ah, look at that magic. How are my fingers here? Yet they're over there. Yet they're over here. Who knows? All right. So Kaylee and Chase, partners.
Writing?
Yes. Yes. Okay. So Kaylee and Chase, why don't you guys work together? Okay. So Chase, where you going? CJ, sorry. CJ. Oh, to the board. To the board. To the board, Kaylee. Running around in circles around the board. Don't you dare. Don't you dare. All right. Here we are. Yes. Oh dear.
He's asking about the periodic table of elements, which has the most.
Take off 1.5. Perfect. Perfect. Whole number. Nothing crazy. Nothing.
Two lines intersect at 1 point.
So lines S and T intersect.
Wait, did you get the picture? I did this stuff already, I know. Okay.
I like your answer. 5.6. I love it, TJ.
Are we doing more up here, or are we going upstairs?
We just did the three.
You just need to do 3. That's all you need to do.
Yeah, you made it. I knew it.
A, B, and C determine a plane. Let's see.
My shoes are soaked. I'm sorry.
Yeah, I was wondering why you had no shoes on. That was perfectly fine.
Yeah,
I completely understand.
My boots are supposed to be light gray.
Oh, so you did come to school with boots. I see. I thought you were
Oh no, I came
in the
to school
water.
with shoes.
Yeah, I thought you were in the water with the. I was like, wow, she
No.
really loves the rain. I get it. I get it. Okay, so let us take a look at. Okay, for B, what did you guys end up getting? Postulate 5.6? 5.6? Yes. Lines S and T intersect at a point. That should be one of the last postulates. Okay, very good. The 3 points that determine a plane, did you guys get 5.2? Very good. Okay, very good. Okay, 5.2 is any 3 between the head. Okay, the 3 points will make a plane. And then P and Q should be the very last postulate, which is 5 point. Which is the last postulate? 7. 7. Very good. All right. Any questions so far on this? No? Okay. Here's another discussion. Now, this is a weird one. Okay. Let's just do example 2A first. So the whole thing is, sorry about that. Okay. So the whole thing is we must determine whether each of these statements, how did that happen? Oh, marshmallows. Right. Okay. So we have 4 different statements on here. We got these 2 example statements and these 2 statements. If 2 coplanar lines intersect, and the point of intersection lies in the same plane as the 2 lines. Oh, that's a handful. That's a mouthful, right? Okay. CJ and Truman, hand me those 2 lines, or not lines, but rulers. They should be rulers. 2, 3. Oh, God. Chuck it at Allison. Did I ask you to chuck it at Allison? Hey,
We're not trying to skewer someone.
Alright. So this will be okay, this is my plane, right? Okay, so it has something to do with 2 coplanar lines. Okay, so I got 2 lines here. What does coplanar going to mean about these 2 lines? Okay, so let's use this line here. Okay, that's the same plane. And what are they doing according to this scenario here? If they intersect. So they intersect on this, Take a 3D space. Right here, okay? Would you say that the point of intersection is on the plane? Okay, no matter where I move it, is this likely to happen all the time, sometimes, or never? No matter where I move it. What would you say this, how often would you say this would occur? Could I ever have a situation where two lines on a plane intersect and it's not on the plane?
No.
And the parameter is, I know some people are like, well, Mr. Wade, I just beat you. No, it's gotta be on the same. That's not on the plane anymore, right? So yeah, don't try to bend the rule. But you do need to be analytical about the next few points. So yes, you have to determine if this is an always, never, or sometimes statement. Always. How about 4 points are non-collinear? 4 points. Think of 4 points here. If you look at this line, can this line have 4 points on it? Okay. Do any 4 points, but the answer's not there. Okay. Can any 4 points floating in space, do they always have to make a line?
No.
Okay. So what would you say this is? Always, never, or sometimes?
Sometimes.
Sometimes. Very good. Okay. So on a piece of paper, right? Or like just like somewhere, like a note card or something, just write something down, okay? Talk with a neighbor, don't share it with anybody else, just you and your neighbor, okay? If you get the next 2 right, I will give you an additional extra credit point for this, okay? If you get the next 2 right. You must do the same thing, always, never, or sometimes, for 2A and 2B, okay? You get 1 shot, so when you're ready, let me know when you're ready. And I will. Okay? Just show me, don't tell me out loud, okay? Just show me in your paper. Oh, sorry, you might not be able to see. She's so used. I grab my lines for you guys. Sorry, my lines. Go for this. Okay. Discuss with one neighbor. You get to talk to one person. Whisper. Whisper to each other. Okay, so that's good. 45 minutes class, we can go through a few sections. Try to break this down. What does it mean? And you ready? Just raise your hand and I'll come around and take a look what you got. Is your final answer? Very good. Anybody else have an answer for this they want to share or no?
For which one?
Well, I don't want to hear what you got. I just want to see. So 2 intersecting lines determine the plane, and 3 lines intersect at 2 points. Do you have that answer? Okay, I want to see it confidentially. Okay. All right, can you show me? Okay. Is that your final answer? Yeah. You're making doubt yourself. Sorry. Okay. Yes. Sorry. interpret these questions. Okay, no, very sorry. And Allison, do you have one? Okay, Allison. Extra credit for Allison. Very good. Okay, Allison, no pressure. Could you tell me what you got for 2A?
Always.
Sorry, you were partners with Truman, right?
Yeah, you got it wrong.
Okay, but did you want to?
No, I thought it was never. I was gonna ask why it's always, but then I realized like, oh wait, she's like,
Yeah, Allison, did you want to explain how you think it's always?
no.
I love your blunt answer. Like, no, I don't, but I got it. Okay. No, just use your hands right now. Use your arms. X. Okay. Everyone make an X right now. Yeah. Okay. Okay. Yes. X. Now you are X. No. I'm kidding. Okay. Doesn't matter. Hey, so move these two These are actually what are these? What are you representing now? Not just the X. What is this?
A plane.
Yeah, you said a plane, but hold on. This represents a line, and this represents a line. They intersect. No matter where I go with it, is it still a plane, Allison? Okay, so no matter where I go with this, it's always going to be a plane, right? So the first answer is two intersecting lines always determine a plane, okay? What about the next one? This one in your book says never. Isn't that weird? But I still went with your answer because it depends on how the heck you interpret this scenario. Three lines intersect in 2 points. Can anybody give me a situation where it does intersect at 2 points? Yes, Catriella.
Well, because it doesn't like it's not specifying that all three lines are intersecting each other. So if you're doing it kind of like making a triangle with them, then they intersect at 2 points.
Yeah. Are these 3 lines intersecting at more than 1 point? Kind of, yeah, right? So you can kind of say, yeah, that's a situation where 3 lines do intersect in 2 points or more than 2 points. So I could say, I could cheat and say this. They're intersecting at 1 point. They're intersecting at another point. Does that make sense? Right? But in your book, I think the way that they're saying is if all 3 lines have to intersect at the same time, the same place, now could you say that they would ever intersect at 2 points? If this was the scenario that they're saying, and you have to be limited to this, then yeah, it's never. But if you include this scenario right here, then it's sometimes. Because right here, this is a scenario, I'm sorry, so this doesn't work out. This is a scenario where there's 3 points. That's not what I wanted. It's asking about 2 points, okay? All right. And now please get out a piece of paper. We're going to finally take, so these ones we could just talk through them. But the next one, we need to take some notes, okay? So if you haven't already, get out a piece of paper and let's write. Let's write. Okay, so very good. Allison, today is week 4, month 4, week 1. All right. Oh, timeout too. Timeout. Hey, Jordan, can you get the lights for me, please? Okay. All right, let me go to my website really quick because I need to check in with you guys on this. Kayla or Kaylee? Kaylee, right? Okay, just making sure. Just making sure I got your name right. Okay, so you might not be, you just joined like Tuesday or Wednesday technically, right? Okay, so I don't think I could hold this to you, so don't worry about this. So if I'm explaining this assignment, don't freak out, okay? Don't be like, I don't know what's going on. I just got in here, okay? That's your situation right now. Because she just joined very recently, okay? But for the rest of you guys, have you guys taken that district exam yet? Have you? Not yet? Okay. So I think, do you guys know? Okay, so who has taken it? Okay, CJ, could you maybe give us some pointers about what we're supposed to do? Like, what did you do to take this exam?
I went into the office. That's it.
That's it? You just walked in?
You just sign up
yeah.
and then
Yeah.
you put it on a computer.
Did you have to go at a certain time or anything, or?
I don't think so.
The reason why I asked is because I actually don't know. And I give you guys the directions. The funny thing is I linked the directions right here. District exam. I gave you this. The truth is Mr. Greenwood made this. I just linked it really quick. I'm like, all right, great. The directions are right here. Okay. Does anybody know why you guys are taking this exam? Think it's to punish you?
No, it's just the teachers.
Well, actually, it's to punish. No, I'm just kidding. It's not to punish you. You're right. And it's not for the teachers. It's not for anybody else. And the other kids in the other classes were like, do we need to study for it or anything? You definitely don't need to study for it. In fact, can you describe, actually, Truman, you took it too, right? What was the test like?
It was pretty easy. It was just like really basic math stuff.
Really?
Yeah.
I didn't know that. Okay. What kind of questions were they though? Like
There were some things about percentages, but it was really basic.
okay. Do you know the point of this exam at all? We just hired not us personally. The district just hired a really big name in math in terms of like how to create good curriculum for math. As you can see, so you might not have experience with this. Maybe I'm giving you a good first impression. But a lot of this year so far has been fairly dry for math, right? In fact, most years have been kind of dry math, right? The argument is that this math that we're kind of currently teaching you may not be applicable to future jobs, okay? In fact, education right now is at a point where don't know if it's properly preparing you guys for the real world, right? Yeah, did you have this discussion?
Yeah, I've had this discussion with one of my old math teachers. Has a brother or something on the board.
Yeah.
And I was talking to him and I was saying, where would I apply this other than if I wanted to be a mathematician or a math teacher? And then we're trying to, like, he's saying, well, there isn't really many places you could apply this. And it's kind of like, oh, well, we've already learned all of this. And now I don't have anything to do with it.
Yeah, I mean it's kind of funny that you learn all this theory and it's not really applicable. Well, his argument was he showed kind of like what the jobs looked like back then when you didn't have calculators, you didn't have a lot of things. You were crunching numbers as an accountant, let's say. Yeah, you need to be fast at math. So some of the tests were built for speed, right? So I'm just saying this because I actually went to one of his hearings. I'm not going to say if I necessarily agree with 100% with what he says, but I like where he's coming from. Okay, so his point is math now you got to be really creative with what skills, anything, English, history, it's got to be applicable skills, right, from what you're learning and how it's going to go in the real world. So we're paying him a lot of money right now to kind of look at where we are right now and then overhaul or maybe change the curriculum slowly to where it becomes a little bit more critical thinking, a little bit more fun, but most of all more applicable for the real world, right? Right now he has no idea where we are though. So he has no idea where to build off of in terms of where we are. So this baseline test isn't just for you guys, it's for everybody in the district right now, okay? So when you guys are taking this, don't over-prepare, don't freak out. It's not like, oh my God, now everyone hates Truman or something, right? It's not like that, okay? Oh geez, all this pressure. It has nothing to do with that. No, everyone loves Truman. Okay? Everybody loves Truman. Sorry. I don't know if, yeah, everybody loves Truman.
Not everyone.
Mateo, how could you be such a cynic in life? Okay, but hey, you're sure. Not everyone loves us, right? Okay, well, we can all be loved, but yes, sometimes it's pessimistic, sometimes it's just honest with the truth and factual. Okay, I digress though. Okay, but yes, so right now all this is just an average. Like, where are we right now? And then with the millions of dollars that we're paying him and the little time that we have to work with him, he's going to build it straight from there, okay? So go in, just have fun with it, just take it and leave, okay? I will give you credit for just showing up. I'm not grading you, okay?
You said you'd give us credit if we had our name signed on the sheet.
Yes, but with the implication that you took the exam
I
too.
know, I'm just,
Not just like, see ya.
I'm just
outta
saying,
here.
it's like, it's funny that that's how you said it, and you didn't say that you signed it and you actually legitimately took it, because
because we're in a nice honor system. Got 3 of them. I know, but I was kind of in hopes that. Oh, whoops! And you were supposed to learn 4-5. Okay, so what time are we at right now? The fat clock right there. I'm like, what time is it? Okay. All right. Papers. Yes, we're to the papers, guys. Okay. All right. Oh, and what test were you here for, Max? Okay. Sorry, guys. Give me 1 second. Talk amongst yourselves for 1 second. Oh yes. No, that's it. Everything should be on it. Leave them on my desk. I have a weird chaos system. Yeah. It's called. Are you? You're taking it live? Oh, you will be. Oh, yeah. They're on fan. This is 1, 2, 3. Yeah. Really? Oh my God! I created all these notes. Oh, I know. I was gonna say, like, yeah. You must have scared. You guys should be taking yeah, you're gonna. Yeah. Six. Yeah. Okay. Okay, got it. You got the hand sheet that says in our group. So sorry about that. I still like this. I'm gonna do it. Okay, go ahead and start writing this down. I'm so sorry. Right? Things just got kind of crazy for a second. Okay, so go ahead and write this down. This should be at the top of your notes. So we learned about postulates But what the heck is paragraph proofs? Postulates and paragraph proofs. We've kind of learned about the idea of proofs, but I haven't actually shown you one. I proved things to you, but we haven't actually done a formal problem called a proof yet. Okay, so don't write this down because this is your book, unless you want to write down the book. So just letting you know, we've actually gone through examples 1 and 2 already, meaning that, and if you guys remember, all the problems in the back of your section or chapter are pretty much just those example problems, right? This last example is write a paragraph proof. And basically the question is always formatted like this. Given that line M, or given that M is the midpoint of a line XY, you must provide a proof to show why xm is equal to my, why xm is equal to my, and then you have to write a proof, okay? That's not really, I think, helpful because it's not, I don't think this is a very easy way to do proofs. And proofs, you're going to learn, they're not always written in paragraphs. In fact, they're written in these weird kind of columns, okay? Or this weird system of doing proofs, right? In fact, in this book, it provides 3 different ways to write proofs. For some of you guys that are more creative, maybe that's a good thing. You have many different ways to prove a problem. But I'm only going to teach you one way to be consistent, so you're not confused, right? Because you can kind of see solving for x to this day, right? Solving for x when your problem is x squared. This is previously in the year, Haley. It's really confusing to know what I wanted, right? And at the very end, we learned about the quadratic form. Anyways, what I'm trying to say is, let's just boil it down to one way, okay? And let's not do paragraph proofs. So I'm going to write down an example problem. Or actually, I'm going to name it first. So the first topic that we're actually going to formally write down is how to write a proof. How to write a proof. And then the example problem will be this. Let's say that given that M, that is a point. This is a point. This is a point. Given that M, which is a singular point called M, is the midpoint of XY, write a proof to show that XM is congruent to MY. Mr. Wee, what the heck is going on? I just wrote something down that I do not understand, and I can't really visualize what this means. Well, if you write XY with the bar on the top, what is that? Can you visualize what that is? What is XY with the bar on the top? Hold on, Len, I haven't heard from you all day. Align XY, but what do you mean by align XY?
Like one end.
One end? Huh? Yeah. Well,
Like one end goes to X and one goes to Y.
yeah, one end could be labeled X, that's a point, and the other one is Y. Does that make sense? What about the point M? Where is that going to go? According to what is given to me, the information that is given to me, that has been written out for me at the very top. Where's M going to go? Len? Okay. Right in the middle, because it says M is the midpoint of XY. Okay? Now we must talk about XM being congruent to MY. Wait. Did anybody miss that? What does that symbol mean?
Almost equal.
Almost?
Roughly.
Roughly equal? It looks like it, right? But hold on. Allison will help you out. She actually knows technically what it means. What did you say it was?
Yeah.
Okay. She is quite right. Yes. Allison has a great intellect. Please turn your handout to the back here. Congruence. and equals. They look, if you read it, they sound exactly the same. If two segments have the same measure, then they are congruent. That doesn't seem like it helps. But read below. What is the difference between equal and congruent? Take a minute to read below and tell me what you think the difference is between equal and congruent. Any ideas as to how to explain the difference between equal and congruent? They sound exactly the same. Not the words, but the definitions sound exactly the same. Yes, Catriella.
Equal is exact and congruent is similar. Generally.
Okay.
Congruents can be, like, if you're talking about geometric shapes, they don't have to be faced the same way or be, like, so if you have, like, a rectangle, one of them could be, like, with the longer side being parallel to the x-axis, and then another could be with it not parallel to the x or the y.
Outside the context of math, could you explain congruence and equality to where?
Okay, so like if like you can have two equal parts of something, so like you can have two cups of water with like an equal amount of like fluid in each cup, but then you could also have like a congruence would be like if you had the same weight of two different metals or something would be congruent weight, so you don't have to have everything being completely similar.
All right. Did everybody quite get the difference there? So hold on. Let's provide one more example. Len, why don't you stand up? Come on up here with me. Okay. Are Len and I the exact same shape? What? Okay. Apparently people think that we don't look alike. So that's funny. Okay. So we would not be congruent. Okay? Congruence means we gotta have the same angles, we gotta get everything in the shape just right. Okay? What could you say is equal between us though? Anything that is equal? Think about intellect, think about strength, weight, height. Anything? Just
Eye color.
okay. Right. We have equal eye color. Let's give it a value. Okay? If his eyes were brown, then I would give it 100%. Okay? If my eyes were brown, it would be 100%. So let's just say we're both brown. Okay? So I know it's kind of weird, but our measures between the two eye colors, right, are equal. We have something that measures equally, right? And let's just say, for the sake of this example, that he and I weigh the same. Okay? We have things that are equal in measure, correct? But are we congruent in shape? So the way that I define it, or I can see it, is that he and I are not congruent. We are still equal in some way, right? The weight, the mass, beautiful eye color, right? The beautiful eye color, okay? Maybe even strength, okay? I would argue I'm stronger, but probably no. Leonard, stop it. Okay, I'm just kidding. Okay, so I would argue I'm faster, right? Okay. But in any case, you guys understand now? Congruence means you gotta be almost exactly the same, not just like in weight and stuff, but even our angles and symmetry. We're not quite the same, right? So we are equal.
So congruent is absolutely exact and equal is like same aspects.
Yeah, like here, I would say the areas are the same.
Okay.
They're equal. Are they congruent?
No.
No, not the same shape. Okay. When you're congruent, you share the same angles, you share like the same side lengths. It got to be almost exactly the same. But here, you don't have to be exactly the same, but you can measure out to be about the same. The areas are about the same. Okay. So in the context of math, that's what it means. Okay. All right. So my little spiel on congruent, because there are a lot of students that go through school just saying they're the same thing, right? A little bit different, just a little bit technically different. Okay, so how do we prove this? Okay, so after all that, how do we prove this? We are going to be lawyers here. Make this table. This is how you write proofs. Be very prepared for what's going to happen, because you're going to have to do this a lot. You remember the first time you guys learned how to graph? It was interesting. It was fun. Do you like graphing anymore?
No.
Why?
Pain in the butt.
It's a pain in the butt. What else?
Go ahead, Kaylee. Just be honest. Right? As long as it's appropriate and you don't you offend anybody here. But look, I think it's tedious, right?
Yeah.
This is gonna be like the new revolution in graphs. It's like a graph. It's like learning how to graph the first time. It's like, well, it's kind of cool, and then later on you might be, I'm a little tired of this, but it's still interesting. Okay. You guys are gonna have to build a lot of these tables to build arguments. Okay. So what you guys are gonna do is you guys have one side where you can make a bunch of statements, and then you got to provide an actual reason behind why you can say it. You always start with only information that is given to you. What things did they tell me? Given that what? What did they tell me? Sorry, I know it's kind of odd, but the first thing they say is that the M is a midpoint of X, Y. That was given to me. That is a piece of information that was told to me from the beginning. I don't have to assume that. I don't have to solve for that. They just told me that. It's like a lawyer. You're just going to take anything you can in the court. Okay. Hey, he said that. That's what he said. He gave us that information. Okay. Objection. Yes. Okay. So xm is equal to my. Normally this would take a lot longer to solve, but xm is congruent to my. That would be my final conclusion. That's what I was trying to prove. This proof is only 2 steps long. I'll say that. It's only 2 steps long, right? In the future, you will have many other proofs, or many other steps to this proof. But anyways, let's take a look at this. xm is congruent to my. What have you learned today out of all the postulates, all the theorems? Which one of those theorems best explains why, when I say if m is the midpoint, Haley, what can I say about these 2 segments here? They're equal. Go back in your sheet of the postulates and theorems. What can we use to justify that? 5.1. Not even. It's not 5.1. Take a look. All over the paper, not just the postulates. Doesn't this sound redundant? If m is the midpoint, then xy and my must be congruent. By the definition of the midpoint, that is true. Okay? It's like saying this. He crossed the street, he gets a ticket. Why does he get a ticket?
He jaywalked.
And then that's a law, right? There's a law against jaywalking. I can't say what it is. It's CalJIT 232-4A. You can't jaywalk, right? That's what I just did. M is the midpoint. That means this and this are equal. Why? Because of the law of, that's called the definition of the midpoint. Does that make sense? So we're kind of like lawyers in math right now. Yes, definition of a midpoint or midpoint theorem. The midpoint theorem. Well, the midpoint theorem. All right, let me give you an example. All right. Hey guys, what did I do with my book? Oh, here we go. Okay, everybody got that? This will seem almost very identical. Oh dear. What time do we have? Okay. Does everybody see guided practice number 3?
Yeah.
Okay, I want you to go on the board and I know it says write paragraph proof, but in your homework from now on, in class from now on, if you say write a paragraph proof, make the table I just showed you. Okay? Don't write a paragraph on it. Okay? Okay, guys, go. Please. On the whiteboards. Find a space on the whiteboard. Solve for that problem right there. Oh, I have a bunch of whiteboards over here. Sorry. I have a lot of other whiteboards you can grab. You may grab a whiteboard at your leisure. Zach, why don't you draw a coconut tree? Why not, man? March tree?
It started off as that, and then
I understand that. In the meantime, you have created approximate. Okay, so please solve that. How do you set up these problems? You're gonna find that there's not much difference between what we just did at all.
Oh, sorry. At 140.
So what?
Because I have a sister and my son's in the school, and Lisa, and my mom don't want her getting caught in the rain when she leaves.
Okay.
So I think that's a little bit early.
Sure.
Thanks.
That's good. I like you, Mateo. You're very straight, huh?
Yeah.
Your opinion. Not even opinion. You say it as it is. I don't think you. Just say it. You just say it straight as it is. Oh, these are really good. Where'd you get these?
Oh yeah, Trader Joe's has them, and then my mom orders the boxes online too.
Really good.
Yeah, they have them like they don't have all the flavors, but they have some of the flavors at Target too.
Oh yeah, that's right. That's right. Yeah, they do sell it. I like the way I see that. The only thing I would argue is that you do have to just write C is between A and B, and AC is between C. Otherwise, you guys go around. This.
Yeah.
No.
No. What?
Okay, so here, Mateo. What you're gonna do is you're gonna build a table, right? Yeah. Statements. And justifications for these. The first thing is you always give me what facts are given to us.
The T between those 2 points.
Between, so you say C is between A and B, right? What else? Did you say anything else?
That HC equals CD line.
Is equal or congruent?
Oh yeah, it is.
Yeah. Congruent to C.
I didn't just draw the line, and that's it.
Okay. And you draw A and B, right? What goes in the middle?
Oh no, C.
What can we say? We're trying to prove what? Prove that what? So write a proof that C was.
The C.
Write a paragraph of proof.
Oh, it's the midpoint of AB.
Would you say it's the midpoint? Would you say it's the midpoint?
Yeah. Have you seen Manifest? Don't worry about it. It's fine. I'll just like that.
How did you say it's in the right spot?
Because like on the line, it's like right in between it, and like I don't know why, but there's a formula that says that.
Have you seen Manifest?
No, I haven't.
It's so good. Oh, really? Yeah. Going straight to like, I like.
Oh, that means that.
My mom was a forensic scientist.
Yeah, it makes
It's for
sense.
anthropology.
Why
It's
aren't
really
you-
interesting. Yeah, studying forensic anthropology. I did that for
That pretty much is
APA
easy.
to the domestics
This is AB,
and the domestics, fleshing mules.
So what definition, what theory of definition says that if this is an so that's how we know C is.
Yeah, well, it's not from like the Captain Wright book. Yeah. So, the show boat. Yeah. So cool. Yeah. She has this thing where she's like all on it.
Right, go ahead and, actually, Mateo, can you get the lights for us? All right. Okay, so you might have wrote it a little bit differently, but please write this in your notes. This is how I want it. This is how you should have had it, okay? Okay, so please make that table. It says, here are the only 2 things that they gave us. They gave us that C is between A and B, right?
And comma, it also says that CAC is equal to congruent to CB. Yep, you know, okay. But what did it not say? What did it not explicitly say about C? Did it ever say that C was the midpoint? Read it again. Did it ever say that C is actually the midpoint? Be a lawyer here. You did not say this in the contract, good sir, so I may sue you now, okay? Did it ever say C is the actual midpoint? It's like saying, did I actually say that you were the boss? It's like, oh, I'm not the boss, and I can't get paid salary boss or the boss salary. Oh no, right? Which, by the way, folks, cynical truth here statement. Read your contracts in the future, right? Don't just be like, all right, that sounds good. I'm good with this. It's like, what? I'm fired. Why? Because under contract, sir, it says that you're not the boss, and you get the. That never happened to me. I'm just saying it could happen. Okay.
We learned that at Honeywell if you went on the Star of India trips because they made you like sign the contract to
Yeah.
go and take the tour, and the kids would sign it, but they didn't realize that that meant that they had to do certain amounts of work on the ship.
Oh, see, read your contracts for that. Did you do that too? Oh my gosh. How did you make it out alive? No, I'm sorry. That wasn't. That sounds kind of sarcastic. I'm sorry. That sucks though. I'm sorry. That sucks. I got roped into doing more work. Okay. So read your contracts. Okay, but again, let me ask you one more time. Did it say that C is the midpoint? At any point? Yes or no? Did it say C was the midpoint? No, it did not. But it gave you enough facts, right? C is between A and B. It's like saying you do lead a crew, right? You do boss around people, but you're not the boss, okay? So C is between A and B. Huh. And then you got two segments like over there. You said AC. You didn't say it. They said AC is congruent to CB. That looks pretty good. Now, let's be rational here. What would you say C is then if it gave you those two statements? What would you call it then if C is between A and B and AC is congruent to CB? By definition, what is C then? It is the midpoint. So you understand how that argument works, okay? C is between A and B. This is this. It never said it was the midpoint, so now you can say it's the midpoint. Why? Because the midpoint theorem explicitly says if your point is between A and B, you should have two segments that are equal to each other. I know I made that really complicated and a lot of talking, okay? But it's a lot more simple than that. You should just be like this. C is between A and B, AC is equal to CB. All right. I guess that's the midpoint. And I think you just use the midpoint theorem. Write it down and the homework's done, okay? You didn't need to talk about it like dramatically like I did, okay? Okay, so that's good, and we're done with 5-1. I didn't realize I completely skipped 4-5, so whoopsie. Okay, so shake it off. Stretch a little bit. We still got 10 minutes of class. I'm going to go through 4-5 as much as I can, okay? And Kaylee, just letting you know, I think, did we talk about the class at all in terms of how it looks and stuff like that? The cover sheet and stuff? No?
I mean, I don't have the cover sheet, but I know
How to get it, right? You know how to get it. You know how to get the cover sheets, right? Okay. I just wanted to show you that on the same website that you get my cover sheets from, I post videos on there, okay? So the videos are to your right, like from this month, this was a month ago, under week 1 videos, if it says it's 1 hour long, that's why I'm up here a lot with this camera and this weird microphone, okay? I am recording myself right now, right? Like not with you guys in it, like I'm recording what's on here, okay? So that means you're actually not gonna see a lot of today, because today I was making you do stuff with the head and stuff like that, right? So I couldn't capture that on film, okay? But the other videos, I think most of you guys can attest that I usually just do the work like the olden way up here, okay? And then you can go home and rewatch it. Anything I don't go over in class, I tape at home and then I put it up here, okay? And then please pay attention to these videos. They're optional, but they're really not in terms of like you should look at them because that's pretty much everything that's going to be on your exam, okay? So yeah, like even though the book has a lot of different problems, everything in our notes and what we go through, that's going to be on the exam pretty much, okay? Oh, what happened to the? Hey, what happened? What's so good? Okay. Give me 1 second. Okay, looks like it's an extended break, guys. Okay, so speaking of which, if I don't get through 4-5 today, there will be a video on 4-5. Sorry, so did you even see any of the stuff I was pointing to just now? Oh. It's like the camera can't take it anymore. Oh my god, this guy just yabbers on.
The question on the.
Sorry, you're gonna have to wait. I got like 10 more minutes of class. I gotta keep with them. Yeah, I can't answer your question right now. Sorry about that, good sir. Sorry about that, good sir. Okay. All right. Let's continue here. Write down this as your note, 4-5. So this is going back to radical equations. Radical equations? What's a radical?
The number that's under that symbol.
Oh,
It's
wow.
the square root sign,
And you're talking about the square root symbol, right?
Yeah.
the radicand.
Yeah. Okay. So if you had to know, this is the radical sign. Okay. And what's underneath that sign is the radicand. We're going to be doing stuff with equations that have radicals. Okay. If I gave you this, and I wanted you to ask, I asked you, what is x by itself? How would you solve for x? How would you get rid of that radical? Yes, true.
Square both sides.
Yeah, you can square it. But, like you said, if it's an equal sign, if it's separated with an equal sign, I gotta square both sides. Because guess what? They won't be equal anymore. It's like saying 2 is equal to 2, and you square one side, and you get 4 equal. What? That's not true. You have to square both sides to make them still equal to each other. Okay? Don't write that down. Don't write that down. That's just extra notes. Then you'd get that x is equal to 16, right? The question is now, your first example problem is how would you solve for this? X plus 5 is equal to x plus 3. I want you to solve for the x value that makes this statement true. Okay? Catch river, okay? Okay. How would I get rid of this radical sign? So the first step to solving this is I want to get rid of that radical sign. I want to get x completely by itself. Does anybody know how I would do that? It's just like what Truman was saying before. How did Truman get rid of the radical sign up here? You just squared it. So what do you think you're going to have to do on the bottom? Or right here? Yeah, you just square the whole thing and it goes away. But whatever I do to one side though, I have to do to the other side. So this gets rid of the square root sign. Now on this side, I have a very healthy x plus 5. Over here, most people make this mistake. Don't make this mistake. They say, oh, everything in here just gets squared. I just distribute that thing in here, and that's x squared plus 3 squared, that's 9. That is not the correct answer. Say it again. Someone said it. You have to FOIL. Okay? What this means is you have to write x plus 3 times, write it out. You're literally taking x plus 3 and multiplying it by itself times x plus 3. But if we remember from the beginning of the year, things are a lot more complicated than just doing x squared plus 9. We have to do this thing called FOIL. So does anybody remember what FOIL stands for? First, outside, inside, and last. So first means the first numbers will be multiplied. X and X. Those are the first numbers in each of these binomials, or these guys in parentheses. They're the first numbers. What is X times X? X squared. Outside means you got to take the outer terms on the outside and multiply. What is X times 3? What is X times 3? It's not X plus 3. What is X times 3? If I add 1x and I multiply it 3 times, how many x's do I have now? 1, 2, 3. Does that make sense? 3 x's. And then inside is the inner terms, 3 and x. What's 3 times x again? Again, it's another 3x. And then the last one is 3 times 3. That would be 9. Okay? Last one, last. And we have this weird statement here. Okay? And then you're going to combine like terms. That's x squared plus 6x plus 9. And then you still have x plus 5 on this side. I would recommend what you're going to do now is you're going to get all the numbers to this side here. So you're going to subtract 5 to this side. So you have x is equal to x squared plus 6x plus 5 minus 5, or plus 9 minus 5. That's plus 4. And then you're going to subtract x from this side. Okay? So I know I'm kind of rushing through this, but I want you to go home and really study over what we're talking about, because the truth of the matter is we're out of time. I can't finish this problem yet. I am not done. I am not finished with solving for x yet. This will continue on in the video. Okay? So does that mean that's it for now? Okay? Go home and if you need to, you can rewatch this video, but watch the next video. I'm gonna post up. Okay? You guys have a good day. Take care. Have a good day.
Yeah, and then we can.
Okay, go ahead.
So first off,
Oh, sorry. I gotta stop this video really quick. Okay, go ahead.
So on here and the answer sheet, it has different